Good morning, students. This is Murthy sir. Today, we will discuss one interesting topic in chemistry, the periodic table of elements, the classification of chemical elements. First, let us see the definition of elements. Elements are pure substances that cannot be separated into simpler substances by physical or chemical means. In the periodic table, 118 elements are there at present. In these 118 elements, around 90 elements are naturally occurring in Earth's crust. Remaining 28 elements are synthetic elements, which are prepared by scientists in the laboratory. When we look at the historical background, there are three important contributions by three great scientists: Dobereiner, Newlands, and Mendeleev. All the three great scientists contributed for the development of periodic table. First, let us see what is Dobereiner's law of triads. Dobereiner stated in his law of triads that the arithmetic mean of the atomic masses of first and third elements in a triad would be approximately equal to the atomic mass of the second element in the triad. Now let us see some examples: chlorine, bromine, iodine, calcium, strontium, barium. So for some examples, this law is applicable, but scientists, when they practically observed, this Dobereiner's law of triads cannot be applicable to all the elements which were there at the time. So because of some limitations, this law is not successful. Now let us see the second contribution for the development of periodic table by John Newlands. He proposed Newlands' law of octaves. Newlands' law of octaves states that if the chemical elements are arranged according to increasing atomic weights, those with similar physical and chemical properties occur after each interval of 7 elements. Later, scientists who observed this law, they revealed that this Newlands was interested in music. So because of that interest, he proposed this law. And when they practically observed this law with different elements which were available at the time, it is not applicable to all the elements. So because of the limitations, this law is also not successful. But Dobereiner's law of triads, Newlands' law of octaves, they are important steps in the development of periodic table. Next vital contribution by Dmitry Mendeleev, a Russian chemist. Dmitry Mendeleev is called the father of the periodic table. Mendeleev's periodic law and his periodic table were appreciated by many scientists. Mendeleev arranged elements in the order of increasing atomic weights. He arranged in a proper way, and also he left some spaces for the future elements which are going to be discovered in the coming years. One interesting thing is Mendeleev used one Sanskrit word as prefix for some elements: Aka boron, Aka aluminium, Aka silicon, like that he named. Let us see Mendeleev's periodic law. The statement that the chemical and physical properties of the elements recur periodically when the elements are arranged in the order of their increasing atomic weights. This is known as Mendeleev's periodic law. So this is an important step in the development of periodic table. Because of few limitations, later it led to the development of modern periodic table by Henry Moseley. Henry Moseley, he arranged the elements in the order of increasing atomic numbers. Let us see two important limitations of Mendeleev's periodic table. Some anomalous series of elements like tellurium and iodine were observed in the table. The anomalous series contained elements with more atomic weights like tellurium 127.6 placed before the elements with less atomic weights like iodine 126.9. So this is one important limitation in his periodic table. And another important limitation is dissimilar elements were placed together. One example for this is chlorine of 7A group and manganese of 7B group were placed together. Chlorine is non-metal, whereas manganese is metal. So a non-metal and metal are placed together. So this is one limitation. So dissimilar elements placed together. Even though limitations are there, his periodic table is a remarkable contribution. Later, it led to the development of modern periodic table. Mendeleev arranged periodic table in the order of increasing atomic weights. Later, Henry Moseley, he arranged the periodic table in the order of increasing atomic numbers. At the time when Mendeleev introduced the periodic table, even electrons were not discovered. Even then, the periodic table was able to provide a scientific base for the study of chemistry of elements. So, in his honor, the 101th element was named as Mendeleevium. So, element with atomic number 101 is named as Mendeleevium in his honor. Let us see what Moseley's periodic law states. He suggested that instead of arranging elements in the ascending order of atomic masses, they should be arranged in the ascending order of their atomic numbers. The number of electrons in an atom is equal to the atomic number Z. So, Moseley's periodic law and his modern periodic table became more successful, and he could justify the placement of different elements based on modern theories and laws. Hence, when we observe Moseley's modern periodic table, there are 18 groups, vertical columns, 18 will be there, 18 groups, and horizontal rows, 7 will be there, they are called periods. So horizontal 7 rows, they are called periods, and vertical columns 18 will be there, they are called groups. And this periodic table is divided into 4 blocks: S block, P block, D block, and F block. S block and P block are together called representative elements. D block elements are called transition elements, and F block elements are called inner transition elements. And the respective elements, they are placed in these 4 blocks based on the differentiating electron. What is this differentiating electron? The last incoming electron in the outermost shell. If it goes into S subshell, then the elements will be placed in S block. In the same way, if the last incoming electron, if it enters into P subshell, then the element will be placed in P block, and so on. Now let us see what are S block elements. In S block elements, alkali metals and alkaline earth metals are there. These are highly reactive elements. So 1 and 2 groups. In one group, hydrogen is there. Along with hydrogen, highly reactive metals like sodium and potassium are there in that 1A group. For these S block elements, last incoming electron, that is differentiating electron, enters into S subshell, so they belong to S block. In the first group, that is alkali metals, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium are placed. In the second group, that is alkaline earth metals, beryllium, magnesium, calcium, strontium, barium, and radium. These are placed in alkaline earth metals. Friends, now let us see the elements of P block. In P block, groups from 13 to 18 are there. And all these groups, they have family names. Group 13, the boron family. Group 14, the carbon family. Group 15, the nitrogen family. Group 16, the oxygen family. It is also called chalcogens. Group 17, halogens. And group 18, noble gases or inert gases. Let us see the elements of D block. In D block, groups from 3 to 12 are placed. Students, in this D block, most important metals like iron, copper, gold, silver, all these are there in this D block. Copper, very good conductor of electricity. Iron, it has so much commercial value. Students, gold and silver are used in ornaments. They are very popular in jewelry. Students, now let us see F block elements. These two are called lanthanides and actinides. Actually, they are extended from 6 and 7 periods of D block. Most of the elements are radioactive elements and synthetic elements.